Okay, so we are still looking at our Freyer model for series circuits, and next we're going to take a look at an example problem. And so you may want to just copy this exact example problem as I'm going through it. You might want to take some other notes on it. I'll let you decide how you want to do this, but it is helpful to have one example problem on a note sheet, as I'm sure you know. So I just went ahead and set this up already, just so you don't have to watch me do as much drawing. So if you want to pause the video and sketch this out, be my guest. So this is our series circuit example problem. And just to keep it simple for right now, I'm only putting two resistors in series. I'm calling them R1 and R2. And let's go ahead and label some knowns. So I'm going to make this a 30-volt battery. So I'm just going to label 30 volts right by my power supply symbol in the circuit. R1 is going to be 5 ohms, and R2 is going to be 10 ohms. And you can see on the side, I set up a table to fill information in, and you can see I put in the order VIR. Remember, Ohm's law is V equals IR. So the first column is equal to the product of the second two. I just multiply I times R, and that should get me V. I'm going to show you guys a couple other interesting things about this chart that also makes this very useful for setting up circuit problems. So first thing I'm going to do here is fill in my knowns in the chart. So the first line is for, I could put the battery or whole circuit or equivalent, whatever you want to put up there. So I've got a 30-volt battery. So my overall voltage for the entire circuit is 30 volts. Okay, I don't know the current through the whole circuit. I don't know the equivalent resistance of the whole circuit. But I do know resistor 1 has 5 ohms of resistance and resistor 2 has 10 ohms of resistance. So I'm going to fill those in right there. So now, if you remember from our equations, we can calculate the equivalent resistance of the circuit by taking the resistance of each resistor and adding them up. This is a 2-resistor circuit, so I'm just going to take the resistance in R1 plus the resistance in R2, and that is going to get me the equivalent resistance. So our circuit overall has a resistance of 15 ohms. And what's kind of cool for series circuits only is that I just add up everything in this column here, and that's going to get me the top number. Okay, and you may even want to kind of put a double dash in here just to separate out the individual resistors from the whole circuit. So that's just kind of personal preference. Okay, so oftentimes that's the first thing we're going to do. If we know the individual resistors, let's just figure out the equivalent resistance because that's pretty easy in a series circuit. The next thing that we can do is figure out the current that is going through the entire circuit. Okay, because I can see here, I know the voltage. I know the resistance for the whole circuit. I only have one box empty. For any of these, if I know everything but one box in a row or in a column, I can figure out the missing value. So I'm going to use Ohm's law here. So voltage across the battery equals current traveling through the battery times the equivalent resistance of the circuit. And you can plug and chug there and then solve, or solve first. I like to solve first. And that means I'm just going to take the voltage across the battery, 30 volts. I'm going to divide that by the equivalent resistance that I just calculated, that 15 ohms we calculated up here. And you'll see I made nice easy math here. So 30 divided by 15, that's going to get us 2. Okay, and then we double check. We're trying to find current. Current is an amp, so I'm going to put an A over there to label that in amps. Now, when I'm filling these numbers in the table, notice I'm not using the units. That just helps keep things from getting too messy. Okay, so now I know the resistance for each resistor. I know all the information for the circuit, but I still don't have filled in the voltage for individual resistors or the current. So let's also remember from our equations that in series circuits, the current that travels through the battery is the exact same amount of current that goes through each resistor. Because a series circuit is one big loop, all of the current has to go through every single resistor. Since I just found that 2 amps of current flow through the battery, that means that 2 amps of current flows through resistor 1, 2 amps of current flow through resistor 2. So I'm just going to put 2 amps here. Okay, and if I'm just filling in the chart, I can just take whatever my current is here and just fill that on down. Okay, so all of those current values are going to be exactly the same. Now, hopefully you can see I've got my rows here. I'm only missing one box. So we can use Ohm's law for resistor 1 to get the voltage, since we know current and resistance. I can do the same thing for resistor 2. So let's go ahead and try that. So voltage across resistor 1 equals current across resistor 1 times resistance on resistor 1. And we're just going to pull that information right from the table. So we just said that our current through resistor 1 is 2 amps. From your givens, resistor 1 had 5 ohms of resistance. 2 times 5 is 10. Okay, and we're finding voltage. So our answer is in volts. Okay, so now I can just go up here and fill this guy in. This is 10 volts. Okay, now let's do the same thing to find resistor 2. So we're still going to use Ohm's law, but now notice my subscripts are all for resistor 2. Resistor 2 also had 2 amps of current flowing through it. From the given, we had a resistance of 10 ohms. 2 times 10 is 20. And so we get 20 volts. And I can fill this into my chart. And it looks like we're done. Okay, but there's actually one more thing that we want to do just to double check our work. And there's always one relationship left that we did not need to use in order to fill in our table. And in this case, that's relationship between the voltages. So remember that in a series circuit, the voltage of the battery is equal to the voltage drop across resistor 1 plus the voltage drop across resistor 2. So we want to double check and make sure that that fits here. And if I take a look at my table, 10 volts plus 20 volts equals 30 volts. That relationship fits. Okay, so that's just kind of a nice way to double check and make sure that you didn't make some really big mistake early on. Okay, so there is just one basic example problem for solving a series circuit problem.